Let us start with the Biot law. Biot law is an experimental law that is Biot and Savart, which is two scientists, found that if we pass a current into a wire like this, it will produce the magnetic field around the wire. Okay, and they show that the magnetic field produced by the current can be expressed with this mathematical formula. That is, if we have a wire that have the electric current I passing through, and we want to calculate the magnetic field at point P here. The magnetic field at point P will be equal to mu0 I over 4 pi times the integral of ds cross the unit vector r over r square. Okay. This mu is a permeability of free space, which is a property of the medium, magnetic property of the medium, which in this case we are interested in the vacuum. Okay, so we call this permeability of free space, and the numerical value of mu0 or mu0 is equal to 4 pi times 10 to the minus 7 Tesla meter per ampere. To understand the Biot-Savart law, we may interpret this law by take this constant mu0 I. We will interested in the case of the constant I only. If the current change with time, it will be another phenomena happen, but we will not interested in that phenomena now. We will interested in the constant current in the wire only, and it means that I is a constant, mu0 or mu0 is constant, 4 pi is constant, and we can take all of this constant inside the integral and rewrite this expression as integral of dB, right? Where dB is this term. Okay. Again, the physical meaning of the integral is nothing more than summation. So when we say that B is equal to the integral of dB, it means that the magnetic field at point P can be calculated by the sum of the dB, where the dB is this term. And the meaning of this term is that if we have a wire as in this figure and we divide it into a small segment, each segment has length ds, and we define the length vector. Again, for example, if we look at this segment, the length vector ds is the vector that points in the direction of I and have the magnitude of the length of this segment, which is ds. Okay, so we define the length vector as this, and we define the unit vector r, which is the unit vector that points from this segment to point P, point that we want to calculate the magnetic field. So this is the unit vector r. Unit vector r has a magnitude of 1, and the direction point from this segment to P. We define r square is the distance from the segment of the wire to the point P is the r. This is the r. Okay, so we may interpret this as when the current passes through the line or y segment, ds here, it produces the magnetic field dB, okay, where dB can be calculated from the Biot-Savart law in this form, right? And then we calculate the magnetic field from every segment, calculate the magnetic field from every segment, and then we sum this magnetic field at the point P from every segment to get the total magnetic field B, right? So the total magnetic field B is the summation of the magnetic field from every segment on the Y. So again, you can see that integral means nothing more than summation. Okay. So from this definition, we can calculate the magnetic field that generates from any form, any shape of the Y that have the electric current passing through. Okay. In general, we can do that, but in practice, you will see that most of the case we cannot calculate the exact form of the magnetic field because the complexity of this formula, and this is the fact that when you do the integral, most of the integral cannot you cannot get the closed form of the most of the integral. Only some simple case that we can get the closed form. The closed form means you can write the formula as a result or as an answer of this integral. Okay, and we will look at some simple example. Maybe the simplest example may be the magnetic field that comes from the state conducting wire. That we will discuss this next in the next lecture.